talked about how subroutines can be used to organize your code, make it easier to read, easier to debug, all that sort of fun stuff. We did a mini example, I believe it was in here. Yeah, that one. We did a mini example. This guy, there we go, where we just made a code to add some numbers here together and spit them out to the user. Talked about how Python reads this script. Wanted to just do one more day toying with that, namely going through our code from the midterm project and putting that into subroutines, kind of reorganizing it. So at the risk of, how do I say this? At the risk of being pedantic, we're going to just write it so that we're going to rewrite it here, just so we're all using the same thing, and go from there. All right, cool. So let's pull up a new one. Let's see. Call this linreg with subs. Okay, so linear regression computer. And organize it using subroutines. All right, so when we did that project, it had to compute the linear regression for an arbitrary set of data, right? And we did that by finding averages, standard deviation, and Pearson's R. Those are kind of our three things. And then we did some statistics on the back end of it. So as with the addition program that we did on Friday, it has a similar sort of structure to it. We have the user input section, we have data collection, we have data manipulation, sorry, and then reporting back to the user. Those are kind of the three rough sections that are always true. It just matters, the one in the middle usually gets pretty big. So for this particular program, that section is somewhat large. We have computing the information that we need for the linear regression itself. And then we have some statistical analysis that we do on it afterwards, yeah? So we might want to split those out into two different sections, but that's kind of the framework that we're working with here. So when I go to write this, well, I know that I'm always going to have a main part of the code. For standardization, I always call my primary subroutine main. So I just always know, so I always know what I'm looking for. I'm just going to call it main. And somewhere down here, I'll just draw out a separator and just call mains, just so I don't forget to do it later on. So inside of main, I know I need to get user input. I need to compute the regression line, compute statistical factors, and I need output data to the user. Now, those are four things that I need to do, broadly speaking. So I'm just going to throw those comments there as placeholders. And then I'm going to, and then I'm just going to, write a subroutine for each one of those. So if you guys remember, what do we need to do here? What sort of user input do we expect? We call just like X's and Y's, right? So that'll be the output. And then I'll just call the function user input. there anything that we should, is there anything that would make sense that would be an input from this code to that subroutine? Do we need to pass any variables to it? No, this is called, its sole purpose is to create variables for us. We don't have to throw it anything. And it's called, and we know that's going to give us X's and Y's. So I have two variables sitting there. It's two variables because they're separated by a comma. So let's go make that subroutine. Shush. So def, what should I write here? To define the define the subroutine. Yep. Same. It's called the name here has to match the name that I use to call it. So this is calling that function down on line 10. So in order for that to correspond to a subroutine, the names have to be the same. It's the same idea as using the print function. We don't write print. Python goes, I don't know what the crap you're trying to do. Try again next time. All right, so user input. All right, so how do we do this in the midterm project? Yeah, so we said I don't want to input every single number through the input function, right? That'd be like tedious and boring, and it would be impossible. So we're going to have the user input it via a text file. So I'm going to assume user has a text file of data to read in. Assume that the text file has one header line. So say, probably should tell the user that, so just this program assumes input data has one header. I'm going to ask the user for file name, including extension. Then we can read that in. Something like that, right? Cool. So, so in theory, I have data now. Except, am I missing anything here? You got it. Yeah. Shush. Okay. There's numpy. So I have my data. But from this, I want to return X's and Y's to main. I don't want to have to do more work outside of this. I want all the messy code inside of the subroutine. I want to keep main kind of clean and easy to work through. So how do I get X's and Y's? Because in theory, I've read in some text file, maybe something that looks like this. How do I get my X's and Y's out of that? This is essentially Notepad. Yeah, so I've made this text file. That's the guy on the left, and I'm reading it into my code that's on the right. I've run np.load text. All that's loaded into data. The 1122334455. Like if I print data here, see if I can. Let me just. If I, oops. If I print that off, I have a nice little array of values. One column is X's, one column is Y's. So how do I split that up? So I have all my X's and all my Y's in two different things. I could, yes, absolutely. I can do it inside of load text. I can load one column at a time, one column be X's, one column be Y's. I could definitely do it. That'd be a great way to do it. Yes, no problem. There's another way here to do it, which I just want to make you familiar with. So I could go through one by one like that, right? My first column, column 0, that's my X's, right? And I could go through and say, okay, my first X is the first row, second X, but that's like really painful and arduous. I can also do that. And what that colon means is that everything in, let's call it everything in the 0th column, every row in that column goes into X. So if I print, say, X, let me comment this out again. If I did that, whoopsie. There are my X's. They just sliced off a column essentially and threw it into that, and threw it into a different variable. So absolutely, you can definitely load one column at a time. It's a legal thing. It works. I just wanted to do something we haven't used in a while. So we got our X's, we got our Y's. Anything else that the input function needs, that the input subroutine needs to do? No, we just wanted to get the X's and Y's. So we can. So what do we have to do in order to get those values back into main? Rather, does main know what those are right now? No. How do we get them back into main? Okay, tell them what's right. Just that? More? Okay, what do you want to return? X, Y, right. You tell it what you want to return, one variable at a time. And the order is important because the order that you return them in here is the order in which main gets them here. So the first variable in this list is, we'll take the value of the first variable in this list. Cool beans? Name? I'll make that. I'll put this guy over here and name that Z, print Y, Z. Oh, oops. I guess I never used that. Sorry, 1 second. In other words, let's test it. There we go. Yeah. Actually, that was a really bad example. Make that 8, 9. There you go. So that Y is different. There you go. Yeah. It's always in the same order. Yeah, names mean nothing pretty much as soon as you go outside of these subroutine. Put that back to X. I really need to stop doing bad commands. Shh. Okay, there it goes. All right. So we got our user input. Great. That first subroutine is done. And if I look at main, all that code takes up is one line, and which is like super nice because I can just look at this and say, okay, I got my user input there, and I have X and I get Y out of that. So again, this is like one of the nice things about subroutines. It groups things. It lets you look at it a little bit more intuitively. So next thing, computing the regression line. So I'm doing that to get a slope and a y-intercept, right? So I know that those are going to be my outputs. And I know that that's what I'm computing. So I'm just going to make that the name of my function. And the inputs to that to just be my data. Shh. Apparently it really doesn't like me today. Yeah. See if I can turn that down or something. Okay. So what do I call this thing again? Reg line. And I know that I'm bringing in my X values and my Y values. I'll just call them X and Y because that's easy. So purpose this. So how do I do it? How do I compute those things? I know you guys got them written down somewhere. Eventually, yeah. But let's do one thing at a time. All right. So here's our PowerPoint for that. There's M. There's B. So in order to get slope, I need Pearson's R and I need standard deviations. To get Pearson's R, you need Z scores. For that, I need standard deviations, and I need an average. So I need to compute an average, and I need to compute a standard deviation, right? All right. Well, I'm feeling a little, how do I want to say? Happy with what's there here today. So if I go over to NumPy and search NumPy or NumPy standard deviation, I get numpy.std as my standard deviation. It says return the standard deviation of the array in A. And A, calculate the standard deviation of these values. Great. It says everything else is optional. Great. I don't have to care about them. I just have to fill in that first variable there with whatever my array of values is. Great, that's easy. Okay, so how about NumPy average? NumPy.average. Bets on that being it. Compute average along a specified average. Everything else is optional. Just stick in an array to be averaged right there. Great, that's easy. I can do that. So let's do that. So x mean equals mp dot average x. Great, that's easy. Y mean equals mp dot average y. Okay, great, that's awesome. How do I get the standard deviations then? Yep. So, and then what do I put into there? Yep, because it's the same as oh, come on. If I go over to my NumPy manual, it's I call this first guy A. If I come down here, it says calculate the standard deviation of these values, one in A. So yep, that's exactly what I slapped into that first one. Everything else is optional, so I just have to put in the value for A. Great, I can do that. Oops, not what I'm just trying to do. Oh, that'll work. Okay, so y 90% p.std, y, great. Okay. All right, that was marvelously straightforward. Another marvelously straightforward thing about arrays is that you can do math on a whole lot of stuff at the same time, right? If I take, for example, if I print x, I say print 2 times x, what's super, super nice, sorry, 1 second, comment this out. What's really, really nice is that it'll be like I'm doing matrix math. So I can call, if I look at the first array there, that's just x, and the second one's just 2 times x. And just by saying 2 times x, I multiplied everything in x by 2. I didn't have to run through a for loop or do anything else because I was doing the same thing to every array element. So if you're thinking, what the heck, why didn't you tell us this like 2 months ago? It was good for you to learn loops. Now you can cheat. Cheers. Because you have a lot bigger fish to fry now. So in order to compute the z-scores so that I can compute my Pearson's R, it's just x minus the mean divided by standard deviation, right? So I can just say x minus x mean over xstd. And that should compute all of the z-scores for all the x values all at the same time, which is super, super, super sweet. You can do the same thing with y's. Let's just print off the XZ scores just to convince ourselves that it is actually doing what we think that it's doing. There we go. Sweet. So it is indeed working. It's doing everything that we want it to. We have our Z scores. Then if I look at my thing, R is just the sum of the product of the z-scores divided by the total number of data points minus 1. So I need the sum of those. Conveniently, there's a function for that, right? So if this one I'm not sure if I can do. I think I can do it. Hang on. Forget how linear algebra-y it is. No, it's not. Sweet. Okay, so as opposed to linear algebra, where you couldn't multiply those two vectors together, Python defaults to an element by element multiplication. So it'll multiply the first two elements, save that to the new array, multiply the second two elements, save that to the new array, multiply the third elements, save that to a new array. Takes care of everything for you. Isn't it nice? So z product. So that's my zx times zy. If I add up everything in that array, that kind of takes care of the, how's it called, the numerator when I compute Pearson's are. So the summation zx times zy. I got that. I'll just have to divide by the total number of data points minus 1. So that should be how many of those products I have, right? Should have the same number of those that I have data points. So R should be Z sum divided by N minus 1. Let's just print R off to make sure that we got that. And if I play cards right, and my input is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, R should be 1, because R measures how linear the data is, and that should make a perfect line. So let's give that a shot. See if I've screwed it up. Oh, I might have. Make sure that this is what I'm thinking it is. Okay, that one's right. Did I miss one of those? There's a square root somewhere. be that. That's a standard deviation. That's a square root. Make sure I use the correct definitions of these. Z is x minus x bar over standard deviation in x. Okay. Well, there is one way to figure out what's going on. It's to use our test data. So I'm going to put this into my text file and see what we can figure out, because I obviously screwed something up in here. And then I'm going to print mean, standard deviation, z-score, and r. Let's see what that gets us. Okay, so x bar is 43 millivolts. That's correct. It says that my standard deviation is 28. It should be 31.94. So that's my problem. All right. That makes a lot more understandable. Interesting. Is true. Huh. That's odd. Huh. Okay. Betcha if yep, there it goes. Okay. To use the same standard deviation that I'm using here in the PowerPoint, you have to specify the degrees of freedom to be 1. That's the one that is typically used in statistics. Why they have degrees of freedom equal to 0, I am not entirely sure. Let's just print R with that and do it for our input data of that. See if we get the same thing as in our code. 0.997, go back over here, have an R of 0.997. Great. All right, so our thing works and we know that it works. All right, everyone follow that on this page? Cool. All right, so we got R. So compute slope. Slope was just R times sigma y over sigma x. So slope equals R times standard deviation in the y divided by standard deviation in the x. Y-intercept it's just solving y equals mx plus b for an average value of x and average value of y, right? So y mean minus slope times x mean should be our y-intercept. And that's the whole shish kebab, right? Anything else we need to do there? Anything we need to do with putting that? So how do we get this data back to the main subroutine? Rather, what do we want to put back to the main subroutine? Yep, we want to return slope. We want to return y-int. Wouldn't R be kind of nice to have? I mean, it's how you usually tell how a line is. So let's return that too. Heck, we could return anything that we wanted. We could return means, we could return standard deviations, but R is really the one that kind of sums it all up. So let's do that. All righty. So going back down to main. Do I have to change this at all? Do I have to modify anything on line 57? Yes. Yeah. Because I have a third thing that's coming back that I hadn't thought of when I first made this. Great, so I have my regression line. Awesome. Great. I can go through, I can do a I can do a t-test on it. I want to give you guys some time to work on your project that's due on Friday. So, so I'm not going to go through locating the critical t value and stuff like stuff like that. Well, yeah, we're not going to go through that, but we are going to find the critical t value. So I'm going to find the critical t value. To get that, well, let's see. If I go back to my PowerPoint, in order to get t, I need the number of data points, and I need r. Well, I found the number of data points before, so I might as well just make that another thing that comes back from the reg line subroutine. Let's add it to the returned. And when I compute statistical things, I'll just pass r and n to it. And then I don't have to. There's called how do I say this? That way I don't have to give all of x and y over and kind of do the same work over. That wouldn't really make a whole lot of sense. I've already done the work. Let's use it. So I'll just feed that in there. Make myself a new subroutine. Def stats. Let's see, and I said t is r times square root n minus 2 over square root 1 minus r squared. So r times that divided by square root 1 minus r squared. Probably should put a comment. That's for now. That's all that I'm going to put in here. But what's nice about subroutines is that I can come back and change that at any point in time. I can just go back and add. tell them to load in a list of critical t values and go from there. For right now, I'm just going to compute what the t value is for that data set. And I'll output everything. Probably should output the t value. Give myself a little space. Say the slope of the regression line is open curly bracket, close curly bracket, slope, and we'll give that to, say, 8 decimal places. Same thing with y-intercept. Same thing with Pearson's R. Except to make it R squared instead of R. And that is that. Dump all the data out to the user and we're done. That's our code. That's the midterm project almost wrapped up into a nutshell. So if I try to run that, there we go. Bam. That was easy. The only thing that might change is add a little bit of space at the front, a little bit of space at the end. So how are you feeling with that? Sweet. One other thing I want to throw in there is the idea of globals. So everything that we're dealing, all the variables that we're dealing with here, we said that these are all local variables, meaning that they don't exist outside of their respective subroutines. So one way that we, let's call it, and this is kind of a safe way to code. It means I can't accidentally change things. If I use X for something else up in stats or output or whatever, it's not going to change. It's not going to get rid of my entire X data set. So and that's like a good thing. However, there are ways to get what are called global variables. So for example, I'm going to say up top, pi equals 3.1415926535897932338. All right, so I'm just going to throw pi up in there. Okay, over here in stats, I'm just going to say print pi. There is not a value of pi in stats. That should like blow up on me and say this does not exist. But I've defined pi up here. So instead of blowing up in my face, it says, oh, okay, pi is that. Because what I've defined is now a global variable. I've defined a variable that's shared by all the subroutines because of where I defined it. I defined it outside of a subroutine and before all of them. It's a global variable. However, say I try to redefine it, make it pi equals 2. Controversial. I know. I'm in trouble. Let me do it there, and I guess in order to show it, I need to do it over here. Sorry. Which call it's not a true global variable per se, because I can redefine it inside of that subroutine. I redefined it to be 2, but that doesn't stick. It's called that the global variable remains unchanged. So with this sort of global, it's kind of like a read. It's kind of like a read-only thing. It's not something that I can go around changing, unless I say that it's a global. Oops. Say that it's a global, give it that, and then, sorry, I'm trying to make sure that I don't forget. There we go. So I declare pi to be a global variable. I tell the program what pi is, and then everywhere where I want pi to be a global variable, in all the subroutines that I want to have access to it, I declare pi to be global. And now, when I run the code, I change the value of pi to 2 in one subroutine, and it's still 2 in a different subroutine. This is what a global variable is. It's something that I can share between subroutines. In fact, if I didn't declare what its value was, this is there, I could create pi in here. And that'd be fine, and I can make a global that way too. I just need to have that. I just need to declare pi as a global, or my variable as a global, wherever I want to use it, or wherever I do use it, if I want to use it as a global variable. I can use pi as a local variable still in this subroutine here, because I haven't brought it in as a global, and the rest of these subroutines won't care because they don't see it. It's not global. It's just global for these guys. So does that make some amount of sense? Okay. So that's kind of just, so that's a difference between a global variable and a local variable, because pi is not explicitly shared between stats and output. It never leaves those two. The only way they can see it is because I've explicitly said that it is a global. Now, dumb question. If I wanted to use stats in regline, could I? Can I just call it? Yes. It's, remember, all that we're doing is making stuff that's almost identical to like the print to the print function. I can use print wherever the heck I want to, right? I can use np.std anywhere that I want to. I can use these subroutines anywhere that I want to, as long as I give them what they want. So like if I wanted to, I could say output slope y-int r, and just to give it something, and it would do it, right? That's the t-value for the data set isn't 5. It's just putting in my value for n, right? Same as this is r, not r squared. Well, actually, it doesn't matter. So I can use those subroutines wherever the heck I want them. And that's that. So this was a little bit more involved than the addition than the addition one. And I think it might illustrate a little bit more why having it organized like this is nice. Because now if I want to, if I need to change anything, I don't have to search through the code. I just come down to main and say, okay, it's a problem in regline, stats, output. Okay, if I want to change the output, I just jump up to output. Okay, great. I'll change whatever I'm going to change in here. If I want to bring in a new stats computation, great. I just change stats. I kind of know where everything is, and I know where all my data is. So it's a little bit easier to keep track of, especially as I get more and more variables. Now I know exactly which ones are shared where. So I know which variables I can and I cannot use. So any questions on that? No? Okay, great. Then the rest of the time is yours to work on your projects. Please let me know if you have any questions. Happy to answer any.